Assalamualaikum. My name is Muhammad Fikri bin Muhammad Hanafi. I am from class AC 11040 and my metric number is 2019 203 448. My lecturer is Asmida binti Alias. The general tools I use for my mini project is this. Okay, first for the water content, introduction is the water content, also known as a natural water content or natural moisture content. Is the ratio of the weight of the water to the weight of the solid in each mass of soil. The ratio is usually expressed as a percentage. In almost all soil tests, natural water content for the soil is to be determined. Knowledge of the natural water content is essential in all studies of soil mechanics. To sign a few, natural water content is used in determining the bearing capacity and settlement. The natural water content will give an idea of the state of the soil in the field. The objective of doing this experiment is to determine the water content in the soil by using the formula of mass of soil solid MS equal to MSDS subtract to MC. Mass of pore water MW equal to MC minus MCDS. So the water content will can find by using the formula which is mass of pore water over the mass of soil solids multiple 100. The apparatus and material for water content is soil sample, trace and weighing balance. The procedure: first, the empty tray was recorded as M1. The soil sample was placed into the tray and was recorded as M2. 3. Spread the soil until it compacted. 4. Let the tray with the soil sample dry under the sun until 24 hours. But in my project, in my experiment, I use oven as a dryer. Number 5. Weight the tray with the soil sample that has been dried and recorded as M3. Finally, the water content can be determined and the data can be obtained. So finally, step 1 to 6 can be repeated for another sample of soils. This is the data of my water content experiment. For discussion, in this test, the water content of the soil was found to be 67.69%. This suggests that water makes up 67.69% of the soil. The amount of water in the mixture can also be utilized to establish a liquid limit. Geotechnical engineers must study soil meant to support structures, pavements and other loads in order to forecast how the soil will behave under varied moisture conditions. Several errors occurred during the trial and safety precautions were required to conduct these studies according to the results. To begin, the soil should be placed in the sun to ensure that it is entirely dry. Next, the experiment should not be conducted on a rainy day because the outcome will be inaccurate. So for conclusion for this experiment is, finally, in conclusion, we have accomplished the goal of the soil, which was to determine the water content of a soil sample. In the soil sample, in the soil water content determination experiment, we also learn how to correctly execute the experiment and apparatus. Okay, for the particle density, the introduction is the soil physical properties control the mechanical behavior of soils and will strongly influence land use and management. The particle density of most mineral soils lies between 2.5 and 2.7 gram per centimeter cube. The range is fairly narrow because common soil minerals differ little in density An average value of 2.65 gram per centimeter cube is often assumed. Specific gravity SGS is defined as the ratio of the weight of a certain volume of a soil solids to the weight of an equal volume of distilled water at a constant temperature. The objective for particle density experiment is to measure the particle density, bulk density, and the moisture content of a soil and to relate to total pore space. So the formula for the specific gravity is M2 minus M1 and over M4 minus M1 minus M3 minus M2. The correctly GS as a kilogram kgs. So the formula of K is relative density of water at room temperature over relative density of the water at 27 degrees Celsius. The apparatus for this experiment is soil sample, bottle of container, show box, weighing balance, water, and tissue. So the procedure is make sure to clean the container first and mark the 3 containers. The 3 containers were weighed and recorded as M1. Pour a soil sample carefully into every container. The container was weighed and recorded as M2. Pour some water until it reached a half of the container. Then put the 3 containers into the shower box in 1 hour. After 1 hour, take the containers out from the shower box and fill the water until it fully completed. The container was weighed and recorded as M3. Empty the container and pour some water until full, and then weigh the container and record as M4. This is the data that I got from the experiment. So the discussion is we calculate the average specific gravity from this experiment, which is 2.2. We can figure out how much air and water can be held in the soil profile by looking at the porosity. We can also figure out how quickly air, water, and heat will move through the soil. We can forecast the behavior of the soil, flooding, identify how the soil may change, and assess how the soil may be best exploited for human activities now based on the information we have gathered. For the conclusion is finally, in conclusion, we have accomplished the goal of this experiment, which was to estimate the specific gravity of the soil and determine the particle density of the soil. Furthermore, the right equipment can be utilized to better the lab test, and the lab manual should be read first before completing the activity to ensure the lab test flows smoothly. As a result, we also managed to conduct the experiment and apparatus carefully. Okay, for dry sieving test, the introduction is soil particle composition is one of the main physical properties of soil that affects soil fertility, and the fractal dimension of soil particle size distribution can be used to quantitatively evaluate the particle composition of different soils. This experiment can be conducted by 2 methods, which is the first one is sieve grain size analysis. This test is to determine the particle size of large particle soils. However, hydrometer test is conducted for finer grain soil. The objective of this experiment is this test is to perform to determine the percentage of different grain size contained within a soil. The mechanical or sieve analysis is performed to determine the distribution of the coarse, larger size particles, and the hydrometer method is used to determine the distribution of the finer particles. The apparatus for this experiment is set up of sieving test container. soil sample and weighing balance. So the procedure is the first weight of the given dry soil sample was recorded. The initial mass of the dry soil sample was approximately 1 kilogram to 2 kilogram. Each of sieve were cleaned and weighed before being used. The sieve were arranged according to the largest opening of sieve size at the top of the smallest and at the top to the smallest at the bottom. The pan was placed below the smallest sieve at the bottom. Then the sieve was shaken manually for 5 minutes. Then the weight of each sieve with its retained soil was carefully weighed and recorded. The weight of the bottom pan with its retained fine soil was recorded as well. So this is the data of my experiment, and this also the data and how to calculate how to checking the grade of this soil sample and to find the type of soil. The type of soil is graded very sandy gravel, well graded and very sandy, and this is the gravel. So the discussion is sieve analysis is a sort of mechanical analysis that determines the particular size range in a soil, which is given as a percentage of the total dry weight or mass. The soil sample is shaken through a series of sieves with progressively smaller apertures for sieve analysis. Sieve analysis results are usually expressed as a percentage of the total weight of soil that went through each sieve. The total mass sample after sifting is smaller than the total mass sample before sieving. According to the result, this is most likely due to the absence of tiny soil particles when the sieve are vibrated. So the conclusion is, in the conclusion, we have achieved the objective of this test. The test is to determine the percentage of various grain size of soil. The percentage of different size distribution of coarse particle also can be determined from this experiment. So for the permeability experiment, the introduction is the permeability is defined here from the equation of the fluid flow through porous media. It represents for composite reinforcements a measure for their ease of impregnation by a fluid resins. So the objective of this experiment is to determine the coefficient of the permeability of coarse grain soils. The apparatus is the container made of bottle, basin, marker, timer, soil sample. So the procedure is first a container was prepared by cutting the top of the plastic bottle, and several holes were made at the bottom of the bottle. Second, the container was placed in the basin and filled with soil until it compacted. Then level points of H1, H2, H3 and H4 were marked above the compacted soil using marker. Then a water was poured inside the container until it full. When water at the level point of H1, the timer was started. Once the water level reached H1, H2 and H3, make it as a lap at the timer. When it reached H4, stop the timer and record the data. So this is the data that I got from my experiment. So the discussion is we were instructed to do the following head test in this investigation. The goal of this experiment is to estimate the permeability coefficient of fine-grained soils like silts and clay. The following head permeability tests involve flow of water through a soil sample connected to a standpipe, which provide the water head and also allows measuring the volume of water passing through the sample. The test can be carried out in a falling head permeability cell or in odometer cell. To determine the coefficient of permeability, Sk, we can use the formula Darcy's law that the flow velocity of proportional to the hydraulic gradient. And this is the formula for the coefficient of permeability. Finally, during this experiment, the experimental outcome may be incorrect. Usually, it is a human mistake that has an impact on the outcome of an experiment. For example, do not take accurate readings of the specimen's diameter or an excess amount of water from the actual reading. So the conclusion is, in conclusion, we have achieved the objective of this test, which is to determine the coefficient of soil permeability. The coefficient of permeability soil obtained from this test is 1.854, a multiple of 10 power of negative 6. This experiment helps us in determining the permeability of soil at particular areas and also very useful in construction. For example, determining drainage features, designing a landslide, calculating seepage for each dams, and determining settlement rate. Lastly, for the last experiment for my mini project is field density. The introduction is the dry density of the compacted soil or pavement is a common measure of the amount of the compaction achieved during the construction. Knowing the field density and field moisture content, the dry density is calculated. Therefore, field density test is important as a field control test for the compaction of soil or any other pavement layer. There are many methods of field density test such as sand replacement method, water replacement method, and core cutter method. For this project, we are going to do the sand replacement method to determine the dry density of in situ soil. The objective of this experiment is to determine the dry density of in situ soil. The apparatus is steel container, weighing balance, trowel, and hammer. For this procedure is first take the dimension and mass of the container to mark at least 2 cm or 3 cm from above the container. Break an empty container, then place the container on the top of the surface and apply a little pressure on it. Use a hammer to push the steel container vertically until it reaches the mark. Then remove the soil that's surrounding the core cutter with a trowel. Continue the excavation until the container can be pulled with soil sample inside it. Then take the container carefully and hold the bottom of the container so it does not spread. Lastly, the steel container filled with soil was weighed. And this is the data from my experiment. For discussion, from the test conducted, the result obtained after calculating all the data and the unit weight of soil as gamma is 1.23 gram per centimeter cube, and the dry unit weight gamma D is 1.15 gram per centimeter cube. It means that the soil is loose, porous, and rich in organic matter. The value of the dry density also proven that the soil has more pore space. The mechanical process of squeezing soil particles together is known as soil compaction. Because of compaction, the air gap in the soil is filled, increasing the density. Engineers must conduct field density testing throughout the earthwork phase of projects, such as building, roadway, and hydropower construction. Soil compaction increases the shear strength, stability, and bearing capacity of the soil. It also reduces soil permeability and compressibility. The conclusion is finally, when the dry density of in situ soil is calculated using the cutter method, the test goal is accomplished. Following the test, we were able to carefully operate the apparatus and calculate the data. The field density test is crucial to utilize and understand as an engineer evaluating the qualities of in situ soil. And this is the link that I have do the experiment in the YouTube. So the safety aspects. First, we must wearing the glove and then wearing the safety boots. The steel container should be completely full of soil or until the mark before taking it out. So then the weighing of the soil plus steel container should be done quickly to avoid the soil from falling out from the steel container. The soil also should be placed under the sun to make sure the soil dries completely. The experiment should not be done in rainy day or the result will not be accurate. Next, we need to always make sure that each container is completely full when filling up the containers. Make sure that the outside of the container is dry to easily get the accurate data. Then conduct the test carefully and specifically following the procedures. Lastly, the sieve must be cleaned and wiped before weighing it. The sieving must be done carefully so that no soil particles scattered on the ground. That's all from me, and thank you.